Hi friends, this is the lecture number 6, part 1. Today we will explain about the dispersion. Okay, what is the meaning of dispersion? We are providing you the lectures based on the applications in our real life. So my request is that please go in the previous lecture because all the lectures these are linked. Okay, so today we will discuss on the dispersion. Now you can see that here 3 types of data. The first one is 7, 8, 9, 10, 11, and the second one is 3, 6, 9, 12, 15, and third one is 1, 5, 9, 13, 17. Okay, if you check mean is the middle one. So this is your mean. Okay, and in this series also this is your mean, in this series also this is your mean. So here the data are different, the mean are same. Okay, so what the dispersion is saying, average or measure of central tendency give us an idea of concentration of the observation about central part of the distribution. Okay, in the first series the number of observation is 5. In here also number of observation 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. The number of observation is 5. And the mean, here is also mean 9, here is also mean 9, here is also mean 9. If we are given that the mean of 5 observation is 9, so we cannot form an idea as to whether from the average from the first series, from the second series, or from the third series. Okay, so in this condition what they have done, in this condition the measure of central tendency are inadequate to give us a complete idea of distribution. The dispersion means scatteredness. Okay, so it means that steady dispersion to have an idea about homogeneity or heterogeneity of the distribution. What is the meaning of this? You can see the first one. In the first series is more homogeneous. First series is more homogeneous. What is the meaning of homogeneous? You can see the distance between two data, 8, 9, 7, 8, 9, then after that 9, 10, then 10, 11. So the distance between the data is, means these data are very near. This 9 it is near to 10, this 9 it is also near to 11 also. Okay, so all data are these all data are just near to other data. Okay, so the first one is more homogeneous. Homogeneous means less depressed than second and third. Now you can see in second and third. In second your mean is 9, but the distance from here to here it is more. From here to here it is more. This is 9, then after that 12, then after that 15. So the distance between this and this data, it is not close to other data. Okay, so in here also your mean is 9, your data it is 5, and the next data it is 1. Your next data it is 13, and the next data is 17. Okay, so these data, these are close to 9, but these are not close to 9. So in the third one is more heterogeneous. More heterogeneous means more scattered, means your data is scattered. Then first and second, this is, you can see that 9, then after that 13, then after that 17. So it is more scattered. So scattered means whatever you have collected the data, so it is not belonging to this family of set. Okay, so it is, the data is very far. In this condition we have the problem, means the data is scattered, and this data it is not scattered, it is less depressed. Okay, so this is homogeneous. So the measure of dispersion, how to measure it? The first one is the measure which express the spread of observation in terms of distance between the values of selected observation. In this condition, the first you will apply distance measured, or you will apply range, or you will apply the quartile deviation. You will use this formula. Or measure of dispersion is second, the measure which express the spread of observation in terms of the average of deviations of observation from some central value. So here we will use the mean deviation. So how to find it? Range. The range means the range of difference between two extreme value. Means you will subtract from the max value and minimum value. Okay, the first observation is this. And how to find the quartile deviation? You will use this formula. Q is equal to 1 upon 2 Q3 minus Q1. What is Q3? What is Q1? Already we have explained. Now mean deviation, how to find it? 1 upon n sigma f into x minus x bar. X bar is the mean. So this is the formula for quartile. Okay, Q1 is equal to L plus h upon f n upon 4 minus c. Already we have explained this. What is the meaning of n upon 4 in the previous lecture? You have divided the data in 4 parts, okay, and you are checking the first part, that is 1 upon 4. If you are finding Q3, so in place of this, all formula are same. In place of this, you have to change. These everything is same. If you are finding Q3, then you have to write here 3 upon 4n. 3 upon 4n means you have divided the data in 4 parts. And you are taking the third part, means 3 upon 4 part. Okay, so 3 upon 4 n minus c. Now if you are finding the decile means Q3 is equal to L plus h upon 4 3 upon 10 n. So you in this here you have divided data in 10 parts and you are collecting the third part. So means 3 upon 10 n. So you have changed this and this. And here also if you are finding the percentile, suppose you are finding the 99th percentile, in this condition the same formula, only you have to change here. You have divided the data in 100 equal parts and you are checking about the 99th part. So 99 upon 10 100 n minus c. So this is the formula for mean. X bar is equal to a, this is the arbitrary value, plus h, this is the interval, or sigma fd upon n. So this formula we will use in our questions. I will solve one question in the next lecture, part number 2. So we will solve one question, then your concept it will be clear. How to use this formula, how to find this dispersion. Okay, the measure of dispersion are two. Number first is the this and second one is the this, and we will use some formula. Okay, I think that you got something. In the next lecture we will solve one question, then your concept it will clear. Okay, thank you so much.